Welcome everyone. This is the second lecture on Altium Designer. In this lecture, we will be focusing on how to design our own library and our own components. In our club, we don't use the default libraries that Altium gave us. We only use the libraries that we designed ourselves and the components that we designed, because for each component that we have, we design them and put it in the library. So we have all the information that we need from each part with the 3D models, the vendor part numbers, where we can buy them, all the information, data sheets from uh, the library. So in this lecture, we are going to learn how to make a new library. So to do that, first we have a project. We are working on it. This is the project from last time, from the last lecture. So all I'm gonna do is, just like the last projects, I'm going to right click on the project itself and add new to project and add schematic library to the project. A schematic library will be added to the project, as you can see, and it's shown here. And I'm going to add a PCB library. I'm not going to add the PCB library right now. The PCB library is added right now, same as the schematic library. So the difference between a schematic library and a PCB library is the schematic library lets you to design a shape for the component. Let's say you want to design a new resistor, a new component, a microcontroller, whatever chip that you're going to use. So you want to design the schematic for that component in the schematic library, and the footprint and the physical shape and appearance of that component specifically will go into the PCB library. Now, we haven't done any PCB design yet, but for the purpose of showing how a library should be made correctly, I'm going to show you first how to design components in the schematic library. And in the next lecture, we are going to learn how to design a PCB library and link these two together, so the components are going to be attached. So for example, we can define what is the footprint for this component or the other component. So first, I'm just going to go ahead and save all to be able to save the libraries. I'm just going to call them first. As you can see, the library changed name. The name of the libraries has changed to first PCB lib and first schematic lib. I'm going to open the schematic lib, and this is what you're going to see. We are going to see an empty space that we can define our new components. I'm just going to make this a bit smaller. We can see our new components. Now, to be able to design new components, where we have projects here, we have to go ahead and click on SCH library, which stands for schematic library. And you can see that this is the space that we are working with for our first component called component 1. Now, I'm just going to open the properties here. Yeah, open the properties here, pin it down. Okay, like that. So this is the properties for the components. This is where we are going to design the component. And yeah, so to do so, I'm going to bring a standard resistor. This is like the default library that we used from Altium. I'm going to choose open standard library. Or I can just go here to the schematic. I believe if I just copy the symbol on this guy to the schematic, no, okay, it doesn't work. So what you're gonna do, I was just trying to carry the symbol easier. Now, okay, I'm just gonna add lines, not pins, but we are just gonna add lines. This might not look exactly like how someone would want, but just for purpose of demonstrating how this is going to work. I'm going to make roughly the shape of a resistor, just like that. Now I think there was a place that I can just change the grid size. Yeah, okay, so if you basically go to Tools, Preferences, under Schematic, go to Grids, and uncheck the bigger grid sizes. So I'm going to uncheck the 100 mil and 50 mil lines, 20 mil, 40 mil, 100 mil, 100 mil. I'm just going to uncheck them. This should allow us to have a better control on the, yes. Better control on the shape of the line. Maybe I'm just going to change it back. Okay. Now that's better. Yeah. I'm going to make a resistor just like that. Maybe I can just make it a bit longer on this side. Yeah. Maybe this is not the shape that you like. You can like play around with the grid size and the length of the components. But typically you want this component itself, in this case the resistor, to be a blue color. So I'm just going to choose this. And after defining those, what we are going to add, a resistor typically has 2 ports. So I'm just going to add the first port to add that, or 2 pins. I'm just going to use the place pin option here. The way it works, I'm just going to put it here and use a space to rotate and put the other one here. So that's basically the 2 ends of the resistor. Now, in resistors, we don't have pin names and pin numbers and stuff like that. So I'm just going to get rid of the, sorry, if you have a pin number, we are just gonna not have it visible. Same with this one. We are just gonna click, the properties is going to open, just gonna hide the values. The designator, it's fine that it's 0 and 1. I'm just gonna, for my own preference, I'm just gonna change it to 0 and 2. So this is pin 1 and this is pin 2. And because I don't like it how long they are, I'm just gonna shorten the length of the pins. I'm just gonna half the length of them. I like that better. Now, basically that's it. That's your resistor component. We are going to call it resistor, like that. Yeah. And now you have the resistor. Because this is a resistor, based on our first lecture, we know resistors are typically called R with a number of the resistor. So what we are going to do in the designator section, we are going to say R question mark. In that way, when it comes up, it shows as R question mark. The question mark can be replaced with a number by the automatic annotation system on Altium or manually. Now, going one by one, we have comment and description. Typically, we want to have essentially a comment showing the value of the component that you are choosing. Let's say we are going to have a 1 kilo ohm resistor. I'm just going to write 1K. And then the size of the resistor. These are stuff that the manufacturer tells you on the website that you're buying from. But let's say for now we are choosing a 1K resistor, the size of it is an 805, and all that stuff. Usually the website that you're buying from has a comment section. We would just usually copy the comment section on the website and copy it down here. As for description, again, most components have a description section. So we are going to just find the description on the website and copy it here. So we have the description for it. But after doing those, we come down to here, which can allow us to add other stuff, which is what we like to have to be able to add the part number, the vendor part number, the supplier, and all of those other values that we want. To do that, I'm just gonna add a parameter and call it whatever I want. I think help URL. Basically, you can put the URL for the data sheet or of that component. I can add parameter designed by, and then just put my name down here. You can add usually components. I'm just going to add the typical components that we add in our club. We have the vendor who's making this product, the vendor part number, and we add the manufacturer. We add the manufacturer part number. The manufacturer part number and the vendor part number sometimes are the same thing, but most of the times they are not, so keep that in mind. The help URL will become useful because you can just, I believe, when you place the part in the schematic, you can just hover on the part, press F1 on a Windows laptop at least, press F1, and it will directly bring you to the datasheet of that component. Right now, pressing F1 doesn't do anything, but yeah, if you have the help URL written here, copied here correctly from the datasheet link, it will come up here. It will come up if you press F1 by hovering on the component. Yeah, manufacturer part number, manufacturer itself, vendor part number, vendor, designed by, and help URL is the stuff that we put in our club on the components. Now, the footprint can be chosen by, if you want to choose the footprint, I believe there should be an edit button here. Let me try to figure it out. Footprints, graphics. I think, okay, yes. Just like the parameters, you have to go add footprint, and now we can choose a footprint for our component. Usually, as I mentioned, what we would do is in the PCB model window that has opened, we can choose the model name and browse for it. Right now, you can see if I click on browse, it will show the libraries that I can choose from. The only library that exists right now is the first PCB library, which currently is empty because we haven't designed it. But let's say the first one is the correct one also. I'm just going to choose that, press OK. It's going to change. It's right now empty because we haven't actually designed the component, and apply that. And now basically here it tells you what is the component that is being used, or like the footprint that is being used and linked to this component specifically. Yeah, and with having the component designed here, as well as the designator, the comments for it, the description, and all of these values for it, you will have a fully designed and part. Now this was a really simple part to design. It only had 2 pins. It's just a resistor. Let's say you want to design a capacitor. I'm going to delete all of this. Let's say you want to design a capacitor. Just do like, I would just do a capacitor basically shape, a standard capacitor shape. I would click this. Again, I want the component to be blue, so I'm just going to change it to blue a bit. And add pins again, just like the resistor. The capacitor also has 2 pins. Again, we don't want the pin name and pin numbers. We are going to get to why we need pin names and pin numbers in general. I'm going to hide them for now. But usually in a component like this that has a capacitor, resistor, an inductor, a diode, you just want the component to be, the designator for the component to be 1 on one side and the other designator to be 2. The name doesn't really matter. You can just get rid of it. And again, I don't like this to be that, the length of the pins, I don't want it to be that long, so I'm just gonna half the length. And boom, now you have a capacitor. So let's say we want to save this. We already made this. This is a capacitor, and we call it C question mark. Typically capacitors are shown with C. I'm just gonna say this is a 10 nanofarad capacitor with an 805 package. Again, the comments and the description for the components are on the website for the manufacturer itself, so it can be found from there. Again, all of these values have to be added. I'm just going to keep this, go to the schematic library and call this, it's called already capacitor. Now let's say I want to make a new component in my library. I'm just gonna, if I'm making another capacitor, I would just copy capacitor and paste. It makes another copy of that. I'm just gonna call it capacitor 2. Now I'm just calling it capacitor 1, capacitor 2, but in our club specifically, we have a specific naming scheme for each component that we make, so we can keep track of all the components. If you see, even Altium's default library have resistor address, resistor bridge, like it has a specific naming scheme. I believe what we do in our club mostly looks like something like cap, and we do the value 110 nanofarad, I said 805, something like that. The style can be found basically by downloading the library for the club and looking at the naming scheme that we used on how to name these. So I would just call the next one, I'm just going to delete this for now, and I'm going to make a copy of the component that I just made, paste. And this one is going to be 100 nanofarad, let's say, capacitor, let's say, and I'm just going to change the values. It's going to have the same values. And now you basically made 2 components. Just keep in mind to fix the naming. Okay. Now you have 2 capacitors, let's say. Now this is for a simple component, again, like a capacitor or resistor, fairly simple to make. To be able to make more complicated components, now I'm not sure if I can find a complicated component in the default library to show you, but let me just try and find somewhat of a more complicated component, maybe. Let's see what they have. Is this a complicated component? Nope, it's not. Oh, okay, something like that. You can see like it's more pins going on. This is an opto oscillator. It doesn't matter at the moment what it does, but as you can see, it has 5 different pins, and each pin does one thing. So it's a more complicated component and it's a more complicated design. But typically, when we want to make more complicated components, we go to the library, the schematic library, we add a new component. I'm just gonna call it, I don't know, mega 32U4. Now this is an actual component, but I'm not sure about the exact configuration. So we call it the name of the component. Let's say this is a microcontroller. It's a complicated one. The way we do it is we right click on this line here and make a rectangle essentially. And this rectangle is going to cover part of the space, just like that. And after doing that, let's say this component has 64 pins, which I believe it actually does. What we're going to do is I'm going to add a bunch of pins. Now I'm just going to call this one designator 1. And the pin name is defined by the manufacturer again. If you open the data sheet for Atmega 32U4, you will be able to see like the details of which pin corresponds to which parameter. So the designator basically says which pin number it is, and the name says what that pin does. For example, let's say pin 1 is VCC, and I'm just going to change this again to shorter ones, because at the same time you can define what kind of electrical type that pin is. In this case, let's say it's a power because it's VCC, and then you can just hold shift and drag this down. It makes the next one. This one is pin 2. It's let's say it's a ground. I'm not sure, but it's a power still, and it's the same length. I'm just gonna keep going. We have a bunch of grounds, let's say, and then I'm just gonna make this shorter a bit. Okay. And let's say we have 2 pins that are like this. One of them is called TX, one of them is called RX. Let's say these are the communication protocols. Again, like which pin, like what is the pin name for each pin number is defined in the data sheet. So you should be able to find that from there. I'm not choosing them randomly. It shouldn't be chosen randomly. Right now I am choosing them randomly to just show how it works. You basically keep going. Again, for like incrementing it automatically, you just hold shift and drag the pin and it increments it. Let's say this one is SCL for an I2C, and this one is an SDA for an I2C. And we have after that ADC 0, ADC 0, and we keep going and going and going until you're done. Let's say this is a design and it's finished. Just like the capacitors or resistors that we showed how you should design them, you have the component name, which again use a specific component name naming scheme. The designator usually for a chip is U question mark, is U1, U2, U3. The comments and description again comes from the website of the supplier that you're buying it from. And all of the components that we mentioned here regarding help URL, design by, vendor, vendor part number, manufacturer, manufacturer part number, all of them should again come down here and be made. Again, this is a more complicated chip. Now, sometimes, one thing I forgot is to define the characteristics of each line. So I'm gonna go ahead and do that. Usually, most of the stuff that we use, they are either powers or IOs, or strictly input or output. We don't have a lot of open emitter, omit collector, high impedance stuff. There is some going on, but not necessarily. So I'm just gonna change these to IO because actually that's an output. This would be an input. The clock is just an IO, I believe. SDA would be IO. ADC is input. again, like the characteristic of its input or output, all of it is in the datasheet. I kind of have a good idea of what an ADC would be, an SCA SCL would be. Otherwise, you have to look for the datasheet and see what pin is an input and one pin is an output. Now, to be able to, yeah, okay, so we have the component made, but sometimes we have a lot bigger components. The components that have 144 pins, we actually have a component in our robots that is 144 pins. And you'd imagine putting 144 pins on the same block would be a really big block that is going to take a lot of space, and this is probably going to only fit 60. So you have to be like going really big to make it work. That is not ideal. That is not the proper way of designing a component. Now, usually what's done, let me just bring this back down to a normal height. Okay. Usually what's done, the powers, like the pins are grouped. Now, in the components that we have, that has the 144 pins, it has different groups of pins. It has like multiple ports. Each port has 16 pins on its own. So like it shows like groups of pins in the datasheet to you. So you can use that as a guideline, or let's say we want to just get rid of all of these power pins and only have I/O pins here, and have the power pins on another block. The way to do that, all you have to do is add a component part. You can click this button here, and if you do so, you'll see that by going to the components here, you see the Atmega32U4 has a part A, which is this one, and a part B. Now we want to bring the power connectors to part B. What I'm going to do is I'm going to make a square here to put the components on it. Typically you want to have the same, like, again, like a sensible design characteristics. For example, the width of these ideally should be the same, so it look nice. But let's say I'm just gonna do this, and yeah, maybe make this a bit bigger, like that. I'm going to cut these and bring them here. Now, if you noticed, I didn't change the pin number because part A and part B are the same component. They are both parts of Atmega32U4. I just put the data pins and communication pins and everything on this side, and I brought all the power pins on this side. The pins are not repetitive. There's no two pin number ones on a chip. Each pin has its own unique designator. So I'm just gonna put that there and put all the grounds on this side, let's say. Some design ideas, some people want to put the ground like this on the bottom and put the power up. I don't like that personally, so I'm just gonna put them here, just like that, and boom. Now you have basically two components, two parts, so you can like organize things better. You can have the power connectors here and the data connectors here, port A, port B, port C, like all of those stuff sectioned out in different components and different parts in the same component, so it is easier to like navigate through the part itself. As you notice, the settings is the same for both of the part A and part B because again, this is part A of component Atmega32U4 and this is part B of the Atmega32U4. I'm just going to save this library. This is pretty much how you design a component in a library. Now choosing, sorry, I have to bring this here. Now choosing the right, like how many pins you have, what pin has what name and all of that kind of stuff, and what pin has what characteristics and all that kind of stuff is in the data sheet that you can pick up from the data sheet of the manufacturer. And obviously there's like other options to make round rectangles. You can make shapes and you can add graphics if you want. If you want, you can take your time and like make a component like the one that I brought it up, like more complicated components like this. You can just design them if you like, how I want. But let's say I'm just going to save this for now. And now we basically have our schematic library. Now, yes, I have to add a footprint for this, and I have to add a footprint for each component that we designed. But right now, we haven't learned how to do a PCB library design, which we are going to do next lecture. So you're just going to stick with the schematic library. To be able to use the components that we just made, all you have to do is wherever you would choose the components. If you don't have this list open, you can just go to the place part and the list should open again. From the list of the options, we can refresh the list, and that should add the library for us automatically. So we are just going to click that, and as you can see, now the components that we made are here. So now when we want to place a 100 nanofarad capacitor, we are just going to choose this one, bring it here. Now you can see like the component that I designed is much bigger, so you have to like play around and like make it smaller. But I'm just going to delete these wires. Actually, you know what? I'm just going to, yeah. So going back here, if I want a 100 nanofarad capacitor, all I'm gonna do is put a 100 nanofarad capacitor in my design. If I want a 10 nanofarad capacitor, I'm going to put a 10 nanofarad capacitor in the design. And because I have all the information for that capacitor regarding like the data sheet, who designed it, what is the vendor, what is the vendor part number, who's the manufacturer, and all that kind of information, and define the footprint and the 3D models for it correctly, when we get to the end of the design and we want a full accurate list of the parts that we need in our design, we can just generate it automatically and be sure that the components are right and we can find them in the market. Now for adding a component like Atmega 32U4 that we designed, let's say, we can just double click on it. As you can see, the part A of the component will be added first, and it will be shown as U?A. And if I keep going, part B will be added. And if there is a part C will be added. So how many ever part you have will be added automatically. Now these two components, these two seem like two different components, but they are not. The way you can recognize that, the reference designator for this is U?, which I'm just going to change to U1. Yeah, I'm just going to change this one to U1 as well. Now you can see that this one is U1A, this one is U1B, and that's how you basically design, like, you know how they're connected together. So I'm just going to redo this. Yep. I'm gonna change this to U. I think you can just unlock this and make that U1 and U1 again. You can choose which part this one is. This one is part B. You can just change it to part A, but it is part B, so I'm just gonna keep it at part B. So now Altium knows this is U1 and this is also U1. They are the same component. And they're basically from the same part, but for organizing them better, we divided it into two different parts on its own. And that's how you place the multi-part designs into your design. And let's say you want to connect them to the ground, you just bring ground here, just like the stuff that we learned from the last lecture, and connect them ground like this. Now I don't like connecting them directly to the wires like that. I'm just going to do this and this and this. Now it's connected to that. And then let's say we have VCC, we want VCC, so I'm just gonna do this and connect that like that. And that's how basically you can connect the component that you just made to the rest of your design. In this way, now you know how to make a schematic library and how to add components to the library. In the next lecture, we will learn how to make a PCB library and how to define a proper footprint for each of these designs.